Welcome to the Walton Pi. Today we're going to talk about what it means for something to be a symmetric group. So to start off, we're going to talk about permutations. So a permutation on a set X is a bijection from X to X. So for example, if X is the set 1, 2, 3, and 4, one permutation would send 1 to 3, 3 to 2, 2 to 4, and 4 to 1. And a common way that we write this is just listing them in the order that they map to. So 1 goes to 3, then 3 goes to 2, 2 goes to 4, and 4 goes back to 1. So we would just list this as 1, 3, 2, 4. We could have also written this as 3, 2, 4, 1, 2, 4, 1, 3, or any other loop that goes in that order. The convention is just to start with 1 if possible. So that's how we would write this permutation. So if some elements map to themselves under the permutation, we just don't write them. So for example, if 2 maps to 3, 3 maps to 4, and 4 maps to 2, but 1 maps to itself, we don't need to write 1 because it just goes to itself. You could write parenthesis 1 end parenthesis, but we don't need that. So we just write 2 goes to 3, 3 goes to 4, 4 goes to 2. So we just write 2, 3, 4. So for a set of n elements, there are n factorial permutations of those elements. And then the set of all permutations of those n elements, that forms a group, which we call the symmetric group of order n, which we denote Sn. So the binary operation on this group is composition of permutations. So for example, in S4, we have 1, 3, 2, 4 times 1, 4, 3, 2. That gives us 2, 3, 4. Okay, pause. What does this mean? So let's look right here. This multiplication is the same as this. How does that make sense? Let's figure out where 1 goes to. So we start by feeding a 1 in from right here. So we see, okay, where does 1 go? Okay, 1, 1, 1, 1. Oh, here's 1. 1 goes to 4. And now we see, where does 4 go? Okay, 4 goes to 1. So that means 1 goes to 1, so we don't need to write it. Now let's figure out, where does 2 go? Okay, 2, that goes to 1. And then here, 1 goes to 3. So that means 2 goes to 3. Okay, where does 3 go? Well, 3 goes to 2. And then 2 goes to 4, so that means 3 goes to 4. Now where does 4 go? Okay, 4 goes to 3, and then 3 goes to 2, so 4 loops back to 2. So that's what that means. That's how we compose these permutations, and we multiply them together. So, since permutations of a set X are just bijections from X to X, the symmetric group over the set X, denoted S sub X, that's the group of all bijections from X to X. So we can do this over any set. We don't have to do this over a generic number. And then the binary operation on this group is just function composition. And so while these groups exist and are useful to know about, most of the time when you talk about a symmetric group, we're really just talking about the finite symmetric groups, so Sn. So let's look at some examples. S0 is the group consisting of the empty function. The empty function sends nothing to nothing, but it is a valid function, and so it's just the group that consists of that one thing. S1, that's the group consisting of the function mapping one element to itself. Still just one function, so S0 and S1 are essentially the same. They both are just a group consisting of one element. Okay, S2, that is the group that consists of the element 1, the identity, it doesn't do anything to anything, and then 1, 2, it switches the two items. S3, that's the group consisting of the permutations 1, 1, 2, 1, 3, 2, 3, 1, 2, 3, and 1, 3, 2. S4 now, there's going to be quite a few. Remember, there are n factorial elements in each group, so 4 factorial, that's 4 times 3 times 2 times 1. That's 24 elements. There's going to be quite a few things we list. So we have the identity. We have all transpositions. So transpositions are permutations that just switch two elements. We have a whole bunch of 3 cycles. We have a bunch of 4 cycles, and we have a bunch of pairs of transpositions. And all of these permutations together, there's 24 of them. There's quite a few. So, I hope this made sense. I hope this was a helpful introduction to what symmetric groups are. If it was, please like and subscribe. It really helps me out. Check out some of my other videos, and if you have a topic you want me to cover, leave it in the comment section down below. I hope you have a great rest of your day, and good luck with all of your math.